Hello everyone. Today I'll present my study on AI-assisted spatio-temporal analysis of forest cover and carbon dynamics in Northeast India, focusing on Nameri National Park, Assam. Using remote sensing, GIS and machine learning, we examine how forest cover and vegetation health changed over time. Northeast India, a biodiversity hotspot under pressure. Northeast India is one of the world's richest ecological regions, but it faces increasing pressure from land use, change, settlement, infrastructure, and shifting cultivation. Because of these landscapes are difficult to monitor on the ground, satellite-based analysis is extremely useful for tracking environmental changes. Now coming to the case study, Nameri National Park. Our case study is Nameri National Park, located along the Assam-Arunachal Pradesh border. It is an important ecological corridor, but is increasingly affected by encroachment, river dynamics, and changing land use around its boundaries. Research objectives. The main objective was to analyze changes in forest cover, vegetation health, and carbon stocks over time using freely available geospatial tools. We also compared the finding with broader patterns across Northeast India. Methodology. We use satellite imagery from the Microsoft Planetary Computer and process the data in Google Colab using Python. Dry season images from 2015, 21, and 26 were selected, corrected, and analyzed through a reproducible cloud-based workflow. Now coming to the vegetation indices, to measure vegetation health, we calculated NDVI, SAVI, and MSAVI. NDVI measures green area, while SAVI and MSAVI reduce soil background effect, making them useful for floodplain and transitional landscape like Nameri. Now coming to the result, forest decline and fragmentation. Our results show a major structural shift in the landscape. Dense forests declined significantly by 2026, while open forest, bare soil, and build-up areas increased. Overall, the landscape became more fragmented and less green over time. Now coming to the NDVI trend analysis. The NDVI trend confirmed this decline. By 2026, more pixels shifted into low and moderate vegetation ranges, indicating a large-scale reduction in vegetation health rather than isolated local changes. So now coming to the system validation. To validate the classification, we use a spectral rule-based reference approach on Sentinel to imagery. The model achieves 69.1% overall accuracy and a Cohen kappa of 0.614, showing substantial agreement. Now coming to the carbon dynamics, we also estimated the climate's impact of forest loss. Over 11 years, the region lost about 329,876 megagrams of carbon, equal to nearly 1.21 million tons of CO2 equivalent. This highlights that forest degradation is also a major climate issue. Now coming to the regional context, Nameri is not an isolated case. Similar studies across Assam, Arunachal Pradesh, Manipur, and Mizoram report comparable patterns of forest loss and land cover change, although some regions also show recovery due to conservation policies. So, to conclude, this study demonstrates how free satellite data, cloud computing, and AI-based analysis can provide meaningful environmental insights. Nameri National Park has experienced significant forest decline and carbon loss, showing the urgent need for scalable AI-driven ecological monitoring across Northeast India. Thank you for your time.